SCAREcrow, Sentinel conservation via aerial reconnaissance and escort.
Hey guys, welcome back to part 2 of the video series on getting SCAREcrow up and running. In the last part we installed our dependencies and I talked about our Docker setup. I also showed getting CLI set up and opening CLI and actually running it with an alias. In this video I'm going to start on the run the project page of our wiki, and we're going to execute the base station, the controller, a manual controller, Python CLI based controller, and the agent. The agent, which is the drone software, the onboard software, will be communicating with the PX4 Sitl, or software in the loop, and the base station will be relaying the positions coming from the agent software down to the controller. And then vice versa, the controller will be sending set points to the agent via the base station. So without further ado, let's go ahead and hop into the run the project page and we'll get started. Okay, so if you aren't at the point where I'm at, where you have the run the project page and you have the container over here, make sure to reference the last video. I'm not going to go through how to actually get this container running in this video, but go ahead and reference the last video and you'll see how to get the container running. For this video, we will need about 4 different prompts. So I already have 2. I'm going to go ahead and spin up 2 more and just have them on the side. One other thing we're going to need is Q ground control. So you can go ahead and get that running too at this point. So as you can see, my Q ground control does not want to run. So for the purpose of this video, I will not show Q ground control. However, I will say when we run everything we run, Q ground control will be able to directly connect to the Mavlink router that we're going to spin up. So it's not a big deal that I don't have it in this video, but if you're able to get Q ground control to run on your computer, just know that it should automatically connect, and if it doesn't automatically connect, you may not have everything set up properly. So without Q ground control, I'm just going to run the project without it. Okay, so for starters, we need to launch a CLI. In the last video, we set up a CLI alias, so all you're going to do is say CLI ampersand and hit enter. I actually already have it running, so I'm just going to pull it up. Alright, so the project is structured with a source file, a bin file for the binaries. The main is right there. Inside of the source file, we have messaging, system, and utils. For this video, we're just going to focus on actually executing the project, so I won't go over the full structure. Again, if you look in our last video, the 45-minute long video, the first video we posted about SCAREcrow, you'll be able to see the structure of the project. But for starters, we're going to look at the main CPP, and then we'll also come down here to the controller Python, and we'll have the manual controller. So for starters, we need to actually build a base station. There's a couple ways you can do this. You can actually build both projects and then run them in their own executable outside of CLI. You can build one of the projects and then run the other project inside of CLI, maybe in debug mode if you need to debug the project. And then you can switch up which project is actually inside of CLI and running. For this example, I'm going to do one in and one out, and the one we're going to do in is going to be the agent. The code that actually connects to the autopilot. So to do that, first we need to build the base mode version of this. So by switching this to a 1 here, this will configure the project to be in base mode. And then all you got to do is hit build. And given your system has been set up correctly and the project is fully installed and downloaded, not installed but downloaded, you should see the build finish. Okay. At this point, we've now built the project, and so all we're going to do is copy the project. And I have already done this, so all I did was Control R to pull up the reverse search, and then I typed in CP, and it found my command. But simply, you just need to type in CP for copy, and then give it the path. So hovergames2/code/bin/hovergames2, and that last hovergames2 is the executable name. And then I'm going to do a / here. Right now, if I were to enter this, it would paste hover games as you see right here. But we're going to actually make this a little bit different, and I'm going to say agent ex. I'm just going to call it agent. And so now if we look at this, it says agent. And actually, I was wrong. We built the base station. So I'm going to remove the agent, and I'm also going to remove HoverGames. And I'm going to copy again, and I'm going to say base station. Okay. Now, just for an example, I can run the base station. And just like that, we're running. But for now, I'm going to close it. Okay. However, I will prep that. So I've got the command prepped. I'm going to throw this on a different display. I'm going to pull in a new window, and we can do the next step. So I went out of order as compared to the actual project commands here, but next what we'll do is we'll spin up the Mavlink router. So to do this, like I said before, you're going to need to execute a couple extra windows. So you can go ahead and skip number 1 if you listened to me earlier, and you've got a fresh window. Now, one of the things we'll need to do is actually get the IP address of our host. So to do that, you'll just copy and paste this command and you'll get the IP address. Mine always happens to be this. Your mileage may vary. Next up, we're going to copy this command, which will run Mavlink router. And then all we're going to do is go back to the alligators and replace that with the number from the last command, the IP address. And all this is saying is basically run Mavlink router, which by default will spin up a TCP connection, or a TCP port that's listening for a connection. And then it's saying also forward all your connections to 14550 at the host, and that's for queue ground control. So if you get this address wrong, your queue ground control will not automatically connect, and actually you probably won't be able to connect to it at all if you get it wrong. And then the last one is just to replicate, or the last one is the one that you actually want to connect to. So I have the drone running on 14550 at 127.0.0.1, which is the loopback address, which means my system. So I'll execute that, and if there's no issues, this is what it should look like. You'll notice the command prompt is taken over by this program, so that's why we have multiple. But at the top, you'll see the first one, the first number, is the address of the autopilot, like I had mentioned before. The second one is the address of the host, which is where queue ground control can listen. And the last one is the TCP connection that the agent code will actually connect to. You'll notice here that there's an error about this main.conf. This doesn't matter to us because I never had you create a configuration file. However, if you don't want to have to type this out every time, you can actually create a configuration file, and then all you have to do is just call Mavlink router D without any extra commands on the end of it, and it will execute your config file. So again, like the last thing, we'll take this and we'll stick it off to the side since we don't need it. Next, we'll go ahead and spin up the PX4 Sitl. So just like last time, we're going to execute another one of these. However, if you already have 4 open, we'll find one that isn't being used, like this guy. Clear out all the Docker build junk. Okay. So now we're going to want to run the actual Sitl. To do that, it's very simple. All you're going to do is, you'll notice on the home drive, we have the base station now because we just built it. We have our shared folder for HoverGames. We have Mavlink router, which Mavlink router, the reason why we didn't have to go into that directory on the last command was because we actually install that inside of the Docker script. You can see the Docker file for that installation. And then we have PX4, which again was installed during the installation step. And then we have third party. And then just for your information, third party is where we store the Mav SDK, which is referenced by our project. So simply cd into PX4, and now you're inside of the PX4 project. And then all we're going to do is copy this command here. If you don't want the gazebo simulation window to pop up, all you need to do is run it with headless equals 1, as you can see here. But I want the window to pop up because I want to see the drone. So I'll go ahead and run that. It's going to go through a build process. Again, if you're if this is the first time running this, it might take a little while because it needs to actually build. This one doesn't take 30 minutes like the other one does. This is more around a minute or two. But it'll build the project, and then you'll be able to actually run the simulation. So here it's setting it up, and you'll notice my Xming window is flashing, and that's because we have our gazebo simulation running. So at this point, we have Mavlink router, we have the base station ready to run, and we have the Sitl actually running. So that's 3 of 4. The last thing to do is execute our agent code as well as the manual controller. So 2 more things. So I'm going to go ahead and stick gazebo off to the side for now because I don't need to see it. And I'll pull it back once we actually start to fly the drone. And just like last time, we can go ahead and move the PX4 off to the side. We shouldn't need that unless we need to restart the aircraft. Alrighty, and just like the wiki says, after we spin up the PX4, we're going to actually build and run the project components. So I jumped the gun earlier by building the base station, but basically what we're going to do is essentially the same thing. So now all you need to do is go back to your CLI and open it back up, and we're going to change this 1 to a 0, which will put it now into agent mode, and we will build agent mode. And again, if everything was set up properly, you should have this build perfectly. If you have issues with Mav SDK, you can check here in the utils and see if it's there. So one of the weird things about Windows and shared drives with Linux is they don't really map nicely. So I had to actually symlink, which is essentially a pointer to another file. I had to symlink this folder out to the third-party folder, which you saw on the root of the Linux container that we're running all of this out of. That allowed everything to build properly, but it had some issues with some building early on in the process with some JSON-related parsing project that they install. So to fix that, I had to do the symlink. Symlink should work because it's built for the container. However, if it doesn't work, that's a good place to look if there are build issues. Of course, if there's build issues with the code, that's a different thing. Okay, so now that we have built the agent, we will actually turn on the base station. So again, we have our base station already set up and ready to go, and it says running base station. You can click a couple times and see that the base station is in fact running. And then what we're going to do is I will pass that off to the side, and I'm actually going to set up so you can see both monitors at the same time. That way we can get a good view of everything that's going on. So give me a second, I'll set that up and I'll be right back. Okay, we're back. As you can see, I've got the, on my second monitor here, I've got the gazebo Sitl running. In the background here, you can see that I've got the Mavlink router running, and then over here you can see I've got the base station running. You'll want to make sure that all of these things are started before you do an agent or a controller. The agent needs this connection running, and it needs the Sitl running, and it needs the base station running. The controller just needs the base station running. So next up, we've built it, and we're good to go, so we're going to go ahead and run it. And I'm going to run it in debug mode, just in case I need to debug. You can run it in run mode or debug mode. I like debug mode because I can put breakpoints if I sense an issue. And so over here, you'll notice the TCP connection was accepted, meaning the agent connected to our drone. And then you can see here that the agent connected to the base station and was assigned an ID of 5. Okay, so now we have 3 of the components of our system connected to the Sitl. We have the base station running, we have the agent connected to the base station, and we have the agent connected to the Sitl. So really it's 2 components with 3 connections. The next step of the process is to run the manual controller. In the next few days, once we have the AI system tested and working, we will put out a video of us actually running this whole system, but we'll just show it running with the AI component. I won't show this whole setup. So this video is the setup video. Next video will be the actual working product or prototype. Okay, so now all we're going to do is inside of this main controller CPP, I'm going to right click it and I'm going to click run. For some reason in this setup, if you debug it, the input doesn't work. So take that with a grain of salt, but for now we're just going to run it, not debug it. And all you're going to say is connect, and that will actually connect you to the base station. You'll notice over here a new connection happened, and it was given an ID of 6. And then it assigned agent 5 to the controller 6. So what it did was it assigned the agent that's running in this window here to the controller, which is running here. So the controller would be the thing that's actually looking at the field and watching the animals move around, and then making the decision to tell the drone via commanding the base station forwarding it to the agent to move to a certain place. So to make that happen, we're going to do two things. First, we're going to actually set the position command that we want to be sent. So what I'm doing now is I'm saying pos for position, and then I'm going to say 5, which is the ID that we get from over here, agent 5, and then we're going to give it a 10 by 10 by 10 position. Now the way the base station is set up, it will actually subtract 2 from the Y location because of how the drone will be placed relative to the base station when we deploy this, and the Z will be actually not used, and it'll be stuck at 2 for safety, so, and for simplicity. So realistically, the controller will be sending an X and a Y command, and the Z will be ignored. But anyway, we'll set all 3 of them for completeness. And one other helpful thing, if you just type in help, it'll give you all the commands, so you can see all the commands we're using. The next command we're going to do is pos and then start. So this will actually turn on a thread that's going to send the position. The second I click this, you'll notice the drone will start to go into a setup phase. So if I run that, click back over here to the drone, you can see now the drone is actually going into a takeoff state. And you'll notice the drone is actually raising up. So sometimes there's this bug that happens with the Sitl where the drone doesn't want to take off and a failsafe happens. And you might see it up here somewhere, but yeah, right here, no local position. So when this happens, you just have to restart everything. I'm not sure what the issue is, but for some reason the Sitl doesn't want to work. So I'm just going to kill that. I'm going to pull up my PX4 prompt, Control C, up arrow, enter. That'll relaunch the gazebo simulation. And then I'm going to come over here, and you'll notice my connection to my Mavlink router died. So I'll run that again, and then just for completeness, I'm going to rerun the base station. And because I still have the manual controller running, I'm going to say shut down. And that shut down, and we will rerun the base station one more time. Okay, so now we have the components that we need running. So now we can turn on the actual, well, first I'll get this window set up for you. Okay, now we have everything set up, and I can execute our agent code. So our agent now will turn on. You'll see it pop up over here that it's connected. You'll see the connection over here, which tells us we're connected to the Sitl properly. And then we know that we're running. Okay, it's setting up. You'll notice it's got the agent ID of 5 again, and TCP connection. So we're connected in both places. And just like last time, we will run the manual controller. And just like last time, we type in connect, which makes that connection to the base station. You can see that we got assigned agent 5. And we will set what command we want to set to agent 5 by saying pos agent ID XYZ. And then we will actually command agent 5. And it's doing local position again. Alright, I'll be right back. I'm going to restart the PX4 and then I'll be back. Okay, we're back. And because I'm lazy, I didn't restart the base station. So what you'll notice is when I connect the agent again, it gets given an ID of 7, and then ID 7 gets assigned to controller 6. However, controller 6 is no longer connected. So when we run controller 6, we'll get controller 8, and then it will reassign agent 5 and 7 to controller 8. Agent 5 no longer exists, and controller 7 or 6 no longer exists, but that's an improvement for the future. Again, I will now command agent 7 with a position of 10, 10, 10, and actually we'll just do 5, 5, 5 this time. Okay, and you can see XYZ, alrighty. And then I will say position start, and you can see the start commands are starting. Alright, there you can see it actually took off that time. And now it's flying to the point 555. And if my Q ground control would work, I could show you that it's actually at 555, but actually it's at 532 because remember we subtract 2 from Y and we set Z to 2. 2, 2. Alright, so now if I want, I can change the position of 7, and this time we'll give it 10, 10, 10 again. And you'll notice the second I hit enter here, the message is forwarded through the base station to the agent. The agent takes that position, changes the set point for off-board mode, and the drone receives that new set point and flies to that position. It all happens just like that. So the second I hit enter, the drone starts to fly. Now you can imagine a human not typing in these numbers, but a machine that's watching a field actually sending a new position every, second or 5 or 10 times a second. And so what actually will happen is Adam's reinforcement learning algorithm will be using this Python interface to send repetitive commands of positions when it senses animals within our keep out zone. And similar to Adam's project, once the Python interface stops sending position commands, the agent waits 2 seconds. If it doesn't get another command for a position, it then returns to base and lands. So 1, 2, now it returns back to base. And if we go back to the actual thing, we'll see that it's returning home. Once it finally settles at the correct home location, it'll command a land. And then once it's on the ground landing, it disarms, and then it waits. And so to simulate Adam's system finding another animal, we will do the same thing we just did, and we will set position 9 to 555, position 7 I mean, to 555, and then we will start again. And as you can see, the drone's going through its takeoff process. It raises up, gets to altitude. Once it achieves altitude, it then moves to point 532. And then as different position commands are made, the drone will travel to those commands. And just like that, I can command it back also if I want, or let's try this, we'll do a -7. Don't know where that's going to go, but yeah, as you can see, it flies around. So again, I'll shut down. 1, 2, now the drone will want to fly back. And once it attains altitude, which is what's happening, it's waiting for it to be at the 2-meter altitude, it will then return to the ground and land. So there you have it. The controller on the ground commands the agent via messages sent to the base station, then routed up to the agent, which is the onboard code that uses the MAV SDK to then set the position and run it through a state machine first, but then ultimately set the position of where the drone should go to. So as the controller on the ground changes where it thinks it wants the drone to go to, it can change that command and the drone will fly to that command. Once the controller on the ground decides that it no longer needs to command the drone will wait 2 seconds for a timeout of no more messages coming in, meaning there's no more animals in the keep out zone that the controller can see. The drone will then go to a return to launch pattern where it flies back 2 meters above where it took off. Once it reaches within 0.2 meters of 2 meter altitude, it will then descend down to the ground, at which point, once it touches the ground, it disarms, and then it goes into a waiting state to be woken up by a new message coming in for a set point. So essentially, the language between the controller and the drone are set points, and if there aren't set points, the drone just takes care of itself and lands. So as you can tell, that's our project running. In the next video, you will see the AI actually controlling the drone instead of a human typing in commands. So if you liked the video, hit thumbs up. If you want to see more like this, hit the subscribe button and leave a comment down below if you have any questions or comments. And we'll see you in the next video. Thanks for watching.